Hey guys, welcome back. This is Summer again from Alibaba Cloud Database Product Team. I don't know how many of you are waiting for this update, but I do know we are and will be always here to share our thoughts on database with all of you every week. If it's your first time to catch us, do not forget to subscribe for continuous free database courses and live demos. Okay, this is gonna be the last one in the series of general testing on RDS, write performance. So I'm thinking maybe it's time to do a summary, shall we? Well, we started from a messy experiment with a surprising result in the first episode. Performance competition between an on-premise MySQL of 2 vCPU for GB RAM and an ApsaraDB RDS MySQL with only 1 vCPU, 1 GB RAM. And then in the second episode, we did environment checking to find out the truth, where we met performance tuning for the first time. Later in the following 2 episodes, we learned 2 basic tools for benchmarking your MySQL database using Sysbench and Gmeter. Frankly speaking, database performance tuning is a big topic, which cannot explain in hours. It requires a lot of practice and experience that you will never truly understand until suffering the same. I mean, you should try it yourself. Just like what people always say, experience is the mother of wisdom, and genuine knowledge comes from the practice. Okay, next, I will share some tips for your journey to do performance tuning. But before we start, let's see how MySQL works. Because you know how it works, you are more likely to know the root cause when facing a performance problem that you know exactly where to start. Well, as I show on my screen, there are 3 logical tiers of MySQL. One is client, such as CLI, command line interfaces, JDBC, Alibaba Cloud, DMS, and Electra. It's for users to send SQL requests. And the other 2 are MySQL server layer and storage engine layer. Generally speaking, there are 4 components in the MySQL server layer. When a SQL request is sent from a client to the MySQL server, it actually goes to the connector first to establish a TCP connection after authorization. You can use a show process list to see the connection between the server and the client. Then it goes to query cache to see if there is the data that client wants. If yes, return the result to the client. If not, goes to the analyzer to do the structure and syntax analyze. If no errors hints, goes to the optimizer to choose the way to finish the task. As it usually the case, although there are 2 options, CBO, cost-based optimization, RBO, rule-based optimization. CBO is always selected as the best choice for most of us who want less time consuming. After optimizer, it goes to the executor to generate execution plan, complete the task, and get result back to the client. At the bottom is the storage engine, which determines how data is stored, how data is updated, and how indexes work. The behaviors and the formats will vary greatly depending on the storage engine. You can set different storage engine for different tables. If you're not, then InnoDB is the default. Okay, after knowing how MySQL actually works, let's move on to the performance tuning. Here on my screen, I shared some tips for you. What can it be besides hardware performance bottleneck? First, are you choosing the right storage engine for your table? Because we mentioned just now, it influences the way data being stored, updated, and found. Especially, my ISOM cannot be used for transactions, and memory is only for small tables. Then check system variables. There are 6 kinds of key parameters: general, character, connection, log, cache, InnoDB. Besides connection limitation, which is running as an entrance for SQL processing, take special attention to disk relative ones like InnoDB buffer pool size, InnoDB flush log at transaction commit, sync bin log, log bin, and InnoDB log file size and electron, because most performance problems are caused by I/O speed, and compared with memory, the speed of disk is too slow. So, on the premise of meeting the ACID requirements, to get better performance, you should reduce disk interaction as much as possible. In addition, sometimes you may need to change your table structure, removing non-values, set a default value instead, and changing column values type to keep it small and simple. For example, using datetime or date to store a timestamp other than using virtual. Another example would be using int to store IP address to reach better query performance with less storage consuming. At last, to figure out where the bottleneck is, you can seek the help of tools like profiling and explain. Let me show you. First, I need to connect to my ECS. And then connect to my RDS. Okay, show databases, use IMDB test, and also show tables. Oh, table. Okay, first we need to set up profiling. Set profiling equals when. It's on now, and let's do a select. Old tab. It may take a while because there might be a lot of data in the table. Okay, then we execute show profiles. This is a time cost, and show more detail. Show profile to see more detail. We can also learn how MySQL works through the profile details. This is a connector, and then analyzer, and then optimizer, and then executor, right? So this is the most time-consuming part. What about explain? Explain, select from old tab. Okay, this is explain. Let's try another one. Count. Can you see the difference? Obviously, it's quite annoying. Is there any easier way to do so? The answer is yes. I would recommend Alibaba Cloud Data Autonomy Service DAS to do SQL optimization and troubleshooting automatically. Okay, this is all for today. We will stop here. Please be free to show your great talent. If you have better idea on performance tuning, we are looking forward to your voice. Next month, we will launch a brand new series. Guess what? This is also a topic that most of our users desire. What it will be? Let's keep it as a secret for now. See you next time. Bye.